84. We had some technical difficulties, so we are starting a bit later. But let's move to our only presentation today. Nauris Aboliņš, aka Clover, and he will tell us about neat shader effects.
So, hi everyone, my name is Nauris. I'm going to talk about neat shader effects and stuff. Yeah, I've been working in a games company called STT for the past 2 years or so, and I've been working on a few games where you did some interesting effects that I would like to just talk about. I thought they were interesting, so I'm just going to make this presentation. Also, I haven't been making these kinds of presentations for literally years, so this presentation may seem kind of unprofessional maybe, but yeah. So let's talk about what exactly is a shader. So it's basically kind of like a program that describes what color a specific pixel should be, or where a specific triangle or polygon should be in space. And with a shader, you can like do all kinds of interesting things with surfaces. Not just this isn't just for shading. You can also just make a polygon appear in a specific color, or maybe make specific pixels like disappear completely. So you can like clip stuff out of surfaces and make like effects where things are dissolving, for example. Or maybe you can make an effect which is just applied to the whole screen, and you can have different types of contents in there. Not just a texture that's doing some kind of effect, but like you could make a completely procedural shader as well. And a shader can also lately be used for non-graphics related things as well, like physics or particle simulations or deep learning, or just anything you can come up with to run on a GPU, and it should probably run fine. So I'm going to talk about a couple of games that I've been working on at STT. Not like all games. I've been working on a lot of games there, but I picked a few games that had like interesting effects that I'd like to talk about. There aren't like groundbreaking effects or anything. I just thought they were interesting, and so yeah, that's what I'm gonna do. And by the way, all these games that I'm gonna talk about are released games, as I don't feel like I should talk about games that we haven't released. So yeah. So any games that I'm going to talk about, you can just download and see the effect for yourself if you're interested. And also, as an added note, these effects, all these games, they're made for mobile, but these effects can be applied to like PC games and console games as well, just at a larger scale, probably. So the first game that I want to talk about, or rather the first effect, is from the game called Flippy Race. It's a pretty old game, one of the first games that I worked on at the company. And I deliberately chose this particular screenshot because this isn't actually Flippy Race. This is a clone of our game made by the same publisher for some reason. And they also used the chord world effect, which I'm going to talk about now. So the effect is basically if you have like an object in space and you go forwards, it looks like you're kind of moving around a planet or like a sphere. So basically every polygon at the distance, it kind of gets moved down exponentially downwards, and it gives this impression that the world is round. So we added this effect because we didn't want to use fog to hide objects in distance popping in, because in the game you only go forwards, and the level is like generated for you. Yeah, we didn't want to use fog because it looked kind of cheap, so we did this effect instead. Although we did end up using fog anyway for specific levels to add like a dramatic effect, like boss battles or something. I forget, this is an old game. But there were some issues too, like even though it's pretty fast, it had some, like in Unity, if an object is like outside of view, it doesn't get rendered. But this check happens before the shader deforms the model. So if the object is like above the camera, like over here, but because the shader gets like move downwards over here, it will disappear anyway, and you would see how it disappears. So we had to do like some hacks to get around that. I remember for like clouds, we added like a small polygon at the top to just make the bounding box really huge, and the clouds would always just render because the camera would think that the model is still in bounds. Oh, sorry, the polygon was like below it, but yeah, small detail. And yeah, also if you use an effect that should like deform everything in the world, you have to apply it to everything, like all the surfaces in the world. So I had to write shaders for solid opaque surfaces and like transparent surfaces, like particle effects, like all of them needed to have the exact same vertex offsets to run properly. Because if an object didn't use the curved world and everything else did, it looked like that object would go from top to bottom, like from the sky, and then eventually just hit you. So it was like a kind of weird effect. It looked like the object was moving downwards, but it really was just moving forward you with a different perspective. So I'm going to talk a little bit about how to get this effect to work. There are many articles on this. This effect is very common, actually. But without going like too much in detail about like writing shaders, and this is also like mostly just the code that I'm going to show is just all code that you can write in Unity. Like different engines work differently, so but the idea can be applied everywhere, like even in like Godot or Unreal Engine or any other engine really that supports shaders. So the idea that this works is we would like this VV value right here would be like the world position of the vertex for your like any vertex in your particular like material or model, and we would then like subtract the camera position from that. So you get like the what do we call it, like an offset value for that particular vertex position, and then we would apply it like we would like get the curved vector from that, and this is what that looks like. So we would just feed in the offset vector for that particular vertex over here, and we would just kind of move it upwards or downwards by multiplying it with itself. And the idea here is that you multiply these z values like forwards and backwards, like you just like cube it, and you do the same thing with the x value, like on the sides, and then you multiply it with some arbitrary number, which is how much you would want the world to curve up or down. Yes, you can actually curve it upwards as well if you wanted to. And we only apply this value to the y-axis because all we really want is to just move vertices up or down. That's all you need. This doesn't change lighting or anything, but our game had so little lighting that it didn't really matter. And after that, we can multiply that value with the curve number, which is also another arbitrary number or value. You don't really need this, but we use this so that we could disable curvature for specific objects. So for example, if there was like an object in distance and we wanted to move it into the like UI space or something, we could like animate it so that whenever it goes closer to the UI, it would like lose its curvature, and when it would be inside the UI, we wouldn't even use the curved world effect like at all. I don't think we used that effect in this particular game, but I think we used it for some other things. And after that, all that is done, we just add this VV value to the original position of the vertex after we converted it back to object space, because when you by default this v vertex value is like in object space, and that's pretty much how you get this effect. You can add like a bunch of other things to it, but this is the basic idea. You're just kind of offsetting vertices depending on where the camera is. And this effect is very common, actually. Even very popular games like Animal Crossing use this for many, many years. I don't know if they use this particular method to do that, but it's possible, and they only used it in one axis, so you can see like the world doesn't curve on the sides like this, it only curves in the distance like that. Also, another mobile game, very popular one that used this is Subway Surfers. So another effect that's it. Another effect that I would like to talk about is planar shadows, and it's something that a few old retro games use, like Quake 2 and Quake 3, I think, as well. I might be wrong, but I think even the original Half-Life used it to some extent, because it's like the same engine. Not really the same, but similar. But yeah, it's like a base. It's like a very, very rudimentary way of simulating shadows. The idea is that you take a model and you kind of squish it down like to an infinitely thin plane, and then you kind of smear it across the ground, depending on where the light is. So there are some. That's very, very performant, but there are some problems because you need to basically render another model for that, like a copy of your model. And if that source model is outside of view, then the shadow disappears as well. It's the same problem as with the curved world shader that I was talking about. So if you have like a lot of objects on the screen, the camera moves a lot, you can often see that the shadows like randomly disappear on edges of the screen, which is not very nice. But if you put things correctly, if you put things together correctly, then that might not be such a bad problem. Yeah, and this is, as the name implies, this is just meant for flat surfaces. So if you have like a rough terrain, this is not going to work well because the shadows are just planar. They're completely flat. You can rotate them if you want to. No, probably you can. But then you would probably do best if the shadow was like casted completely downwards, in which case you're pretty limited to what you can do. Like you can maybe rotate the shadow on like a flat slope, for example. And I know some games use that, but the things you can do with rough terrain are very limited. So if you want to use this, then you should probably use it for a game that has a completely flat ground. And the game that we use this for does actually have a flat ground. You're going to see that in a little bit. And this is kind of a plus and kind of a minus, is that the shadows are completely sharp. Like they're super sharp. They're just a bunch of polygons anyway, so they don't get like blurred out at the edges or anything. If that's what you're looking for, then this is perfect. But if not, then the shadows might also like look completely out of place. You could like maybe blur them in post-processing, but at that point you might as well just use like texture mapped shadows anyway. So yeah, so like I said, basically the idea is that you squish the model down and then you kind of smear it across the ground. And I'll be honest with you, I didn't write this particular math to get this to work. I modified an existing shader to get exact effect that I wanted. But basically you get like the light direction, and then through some math magic, you multiply your vertices with some matrix value, and you give it a plane height here. And the plane height is basically the height of the ground. And this can be used for a lot of things, actually. As here, for example, I added an extra function for this where if the particular pixel, like any pixel on the model, is below the ground height, it just gets discarded, which means that it doesn't get rendered at all. And this is so that if an object clips through the ground, the shadow also disappears under the ground. If this wasn't in place, then if an object would move underground, the shadow would like stay in place. It would like go in the opposite direction, and it was kind of like a weird effect. So yeah, this is basically how it looks like. If anyone's interested, I can like give you the shader or something if you want. It's very, very simple. I'm surprised a lot more games don't use this, because a lot of games, like especially in mobile, use very flat surfaces anyway. So yeah, this is a solution for that. And on the left here, you can see our new game Agent Action that use these shadows. You can see them like super flat. They don't cast on top of complex geometry. Like I said, they're just flat, and these models don't have any logic for like self-shadowing either. But it fits the art style, and it's fine. And here's a screenshot from Quake 2, where they also used a very similar approach for shadows. So the next effect that I want to talk about is textured fog. And if you ever like made a game in Unity, maybe your first games were like 3D, then you probably tried to use fog, like built-in fog in any game engine. And what that probably means is you had like one color of fog, which is the traditional way of using fog in games. But in this particular game, in Turbo Stars, we wanted to have a fog that we wanted objects to disappear in a distance, and we originally used the curved world, like in Flippy Race. It's a very similar game anyway, but our world geometry became very, very complicated, and it didn't really work well. We got a lot of really very aggressive object disappear. The object started disappearing very aggressively, like what I was talking before. Like distant objects started to disappear, and it was very, very apparent we needed to figure out a different way to make objects like pop in, like outside of view. So I figured that since we wanted to have backgrounds with like images on top of them, like that artists would just draw, that it would be cool if we had like a fog that would blend into the background image. So another problem, the same problem applies with this, where you have to use this for every single object in the scene. And it's not actually very performant. I feel that it's very slow, but our game didn't have a lot of, it was a very low poly, and there weren't a lot of pieces of geometry. It was very simple in that regard, so it kind of balanced out. And another problem was that the background is an image. So we needed, since our camera also rotated like 90 degrees, maybe 180 degrees, and even up and down, we needed to figure out a way to kind of scroll the background convincingly. So there needed to be a lot of hacks for that as well. So I'm going to show you how, more or less, how I did it. It's actually a little more complicated. It's one of the more complicated shaders in this presentation. So, so the idea is that we feed in an image of the background into the shader, or like a global image. In Unity supports this thing where you can specify a global texture, and then every shader that references this particular texture can like use it. So we didn't need to apply this texture to every single material in the scene. We just applied it once. And the idea here is that we have, like, I wrote a function where we can just like apply a fog to any pixel on the surface of any object. Yeah, this is what it looks like. And then you just kind of give the original surface color, and then you also specify the screen position. So this is like the pixel screen position. Now down here, we convert this pixel screen position to a normalized position. So that would be like the left side of the screen would be like the x value with 0, the right side would be like 1, and the top one would be 0 by the y-axis, and the lower one would be 1, or reverse, I forget. And then over here, we also like flip the whole texture upside down. The camera is flipped. So this helps us a little bit with, like, we had these loop-de-loops as well. So the camera would also go upside down, and we needed to do something with that. And over here where there's out_vec, this value is basically a modification of the image in the background, so that if the camera would like turn around or roll, we did a lot of like operations for the background image, so that it would look natural, because the camera would always like shake a little bit or turn left and right a bit, and there was like an ambient rotations as well, and all that needed to be reflected in the background so that it doesn't look out of place. And over here, we kind of like sampled the sky texture using this vector here. And over here, we get like a value from 0 to 1, depending on the distance of the fog. So like if the pixel on this particular surface is like really far away, like over here, then we would need to know how much of the texture it needs to draw on top of itself, like the sky texture. So if it's like further than the the fog start position, and if it's like, and here's like the end of the fog, like if the pixel is somewhere in between, it needs to use like 50% uh, of the sky texture. But think of it kind of like a chameleon would hide in some kind of background, like inside of a background. Like it kind of tries to look like the background itself, but the background is just an image. So the chameleon would be like the model. So the further away it goes from the camera, the more it becomes the background image. It's kind of difficult to explain without going too much into detail on how shaders work, so I'm really struggling here. But yeah, down here we can see that like if the this value here, which is like from 0 to 1, but it also can be lower than 0 and larger than 1. If it's like lower than 0, then it's like really close. So just use the original color. If it's like larger than 1, then it's completely in the background. So just draw the sky texture. And if not, then kind of interpolate between your color in the surface color and the sky texture's color, and then just kind of clamp it. That's not absolutely necessary, actually. So yeah, and this would give the effect that I'm going to show you. But yeah, over here we kind of like get the screen position. This is what Unity uses to compute the screen position of a particular vertex. This is a built-in feature on Unity. In different engines, this might be different. And then over here, I also made it like a shader feature where you can like do a little checkbox. You can maybe make materials that don't have the fog applied. And then you can like apply the fog and input the screen position that we specify over here. And then we just kind of return the color. And this is kind of what it looks like. You can see that in the distance, there's like a ramp with some arrows, but it kind of like fades into the sky. It gives you this impression that the objects in the distance actually get transparent, but they don't really get this transparent. Then we'll be asking, like, why not just make things transparent anyway, like naturally transparent with distance? That would be kind of faster, right? But the thing is, when you have transparent surfaces, the render order between triangles breaks down, and you can't really like sort triangles normally, or rather you can, but it's very not performant. It's not very performant on mobile. So this approach, I think, is actually a lot better, and it's a lot more stable. Like there's no artifacts. This is completely smooth. You can try the game out if you want and see it, or just Google a video. Actually, I got inspired by some old games that used something similar, but they too used transparency. Yeah. So I bet you didn't expect this, right? So I'm gonna talk about a little effect that I made for my own game, where I wanted to make it so that if you run into grass, you you would leave like a trail of like bent down grass behind you, and I wanted that grass to slowly like get up with time. So I tried different approaches. At first, I tried to make it so that the grass knows the point in space where you are, and then it just kind of moves away. But that's not able to like let the grass stay down for a while. It's just a very local effect that only applies to one point in space, or multiple points, but it's still not permanent or anything. And so I made a different effect. I'm going to explain how I did it. So the effect that I made can work anywhere in the world. You can make like a huge piece of terrain with like an insane amount of grass blades, and it would work everywhere on that terrain, because it's a very localized effect. It works only where the camera is. And if you get far away from the effect, it just kind of fades out. So you don't need to worry about like garbage collection or like currently active grass patch or anything like that. And it is very, very simple. It uses a camera that creates a render texture, and then you kind of draw the path that you create while running on top of the grass. So I'm going to talk about that a little bit more now. So this is what the game kind of looks like in the background. So if you run around, the main character or any other character in the game leaves behind a trail of particles that use this texture here. It's a transparent texture that kind of mimics a normal map. And yes, I did render it myself. And the idea is that these particles, they stay for a while and then just kind of fade out. And this is like a very, very simple particle system. It can be disabled at a distance if required. You can do just about anything with it. In this case, if you jump, the particle system stops, but when you land, it starts making new particles because you don't want the particles to affect the grass when you're in the sky, if you jumped. So yeah, you don't actually see this in the game. I just enabled it so you can see what it looks like. So the idea is that we have a special camera, like an orthographic camera under the game camera, and it looks upwards. It looks upwards because I wanted an easy way to sort different particle systems so that if a particle system is like higher up, the one under it would be rendered on top of it. But this can be also done with the camera looking down. It's not really a big deal. And the camera kind of creates like a render texture with this particular color as its background, and it kind of only looks for these particles that under a specific layer. And this texture is dynamic. If you move around, I mean, by dynamic, I mean it's always updating, and that if you move around, it only shows what's in the proximity of that camera. It's actually a lot bigger than this. In this particular screenshot, I just made it smaller so that I wouldn't have to create too big of a screenshot. But this is the end result, and we feed it inside of a shader. Or again, like I previously said, you can specify a global texture for shaders, and this does the same thing. So the idea here is that we get like the difference, like the offset vector for between this particular vertex for every single grass blade. We subdivide the not subdivide. We just kind of take off the camera position there, and then we get the normal position, like normalized position, kind of like what I was saying about the screen space, where this side is 0 and this side is 1. And everything between is like something between 0 and 1. And that's what this does basically. But it does it only for the render texture in space. So like the square that where the camera works. And then we check if the vertex is inside of this square. And if so, we kind of like sample this texture. It's actually a normal map, but I couldn't get it to work correctly, so I kind of unpacked it myself by doing this magic here. So I get the normal vector of this texture. And then everything else is basically whatever you want to do with that texture. So I check if the color's value, like any of the RGB values, is like larger. But if the source model's vertex color is brighter than 70% brighter, then it would do these offsets for it, like just bending away from the texture. And I did this because I wanted to specify that the grass blades are completely solid at the base and they can only be moved sideways at the top. So yeah, this is how that worked. And this right here is just, like I said, basically just something arbitrary that you want to do with the grass blades. Just kind of moves them away sideways, and also a little bit downwards as well. So you step on the grass, not only moves sideways a little bit more, it also the more closer to the center it is, it kind of like moves more downwards. And down here, we also changed the color a little bit so that it appears darker, so that the trail can be more visible. It's actually a lot more subtle than I thought it was going to be, or maybe I'm doing something wrong. Yeah, I think it turned out pretty nice. So, do you want to see it? Do you want to see it in action? Well, I'm going to show you. So, I'm going to just launch the game. I'm going to show it for a little bit how it looks. And yeah, so here's our little guy. We can run around. And as you can see, he does like, you can see that the grass kind of bends down. It's, like I said, it's pretty subtle. But what's really cool is that these are particles, so you can do just about anything with them. So I created a little particle that's not like a blob, but more like a donut, like a ring. So when you land, it does this. So the grass can like moves on the sides when you land. And another cool thing, like I said, like this can be applied to just about any object in the world, including other enemies. So for example, here we have 3 spiders here, and they create very visible trails behind them. And yeah, so this is what the effect looks like. We can run away from them, and you can see that, maybe you can see, maybe not, that the grass kind of gets back up in the distance. So that's a little bit of a limitation, but also I don't think it looks that bad. So yeah, that was my presentation. Thank you. Maybe some of you have some questions, but right now I don't hear anything. I don't know how to get any questions from you guys. But yeah, that was it. Thanks.
Okay, so I will read the questions down if there are any.
We have a little bit delay though.
People say that the effects look nice and soft. I could agree.
Thanks.
So the question is, where did you learn shaders? Did you have some special courses, or how did you do that?
There was a point where, well, I started out by just kind of downloading or more like copying shaders from online whenever I needed something special, like very specific. Like maybe I needed a transparent shader with some like shadow casting, for example. And I didn't really know how to write shaders, so I just kind of like copy pasted whatever shader I can find online, whatever worked. And eventually I started kind of like splicing shaders together. But over time, I just kind of started to understand how it works. And so I just kind of like, I said, what the hell, I could just learn things anyway. So I went online on YouTube and just learned, watched some videos on how to write shaders for Unity. And then I just kind of went from there and learned some new things. But recently I watched a course on Udemy where I learned a little bit more about ray tracing and how to work with the Z buffer. So I learned more about that. But you can probably find all of that online for free anyway. So yeah, it's mostly, I just kind of learned on my own, mostly.
Okay, the next question is, what do you think about shader graphs, URP, HDRPs, and I could add from myself about maybe Unreal Engine's shader graph.
Okay, so making shaders using like visual scripting itself is pretty cool because you can give that to the artist, and the artist can come up with some really interesting things, probably. I personally I'm not really a huge fan of shader graph for Unity, because if you create one shader, it creates like over 40 different types of shader variants for that one shader. And a shader variant is basically a unique shader, but with like different types of like effects or options enabled or disabled. And for some reason, Unity does that, and it makes the compile time pretty long. But that's not really a huge problem. It can still be used, and they're pretty fine. But I think the biggest problem that I don't like about these kinds of systems is that I can't really um, I can't really go very low level on it and like change things around. It's a very high level approach to writing shaders, but they are very useful for artists and prototyping especially. And about universal render pipeline and HD render pipeline, um, I actually use universal render pipeline at work, mostly because we're trying to kind of squeeze as much performance out of mobile as much as possible. But recently, I've come to the conclusion that it doesn't really matter. Um, HDRP is basically just it gives you some new shaders to work with, like sort of industry standard.
Yep, so no more questions. Thank you then, and we'll move on.
Yeah, thank you.
Shit. Čo?
Let's come in.
To je kamer?
Yeah. Kāpēc tu neesmu?
Es nezinu. Kāpēc tu neesi?
Kamera ir? Some difficulties with the camera, but let's move on without the camera, and we have the game. Yes, finally we have the game. So the rules are the same. I will show you a few pictures. You will try to combine them and guess the game. And you can do that in the live chat. And the one who first guesses the game will get Gamedev.lv calendar in his mailbox. So let's move on to the first game, and 3, 2, 1. So, look at the pictures and try to combine them. What do you see? What do you see in the first picture? So, Tiger King. No, it's not Tiger King. Any other guesses? So you see three objects in the first picture. Okay. No, this is actually not hard, but Boobs and cars. No, that's not the name of the game. So
No, Tomb Raider, no.
no. Zoo Tycoon. No.
That car is hard.
Yeah. So
Wildlife, no. Something, no.
Cheetah car. No. So the type of the car. What is the name of the type of the car? It's not SUV. No, it's not the car. It's the type of the car. No, it's not my awesome Blue Opal 3. Okay, this seems to be harder than I expected. No, it's not Truck Simulator. So, ignore the girl in the first picture.
Crossover.
Yes.
Closer.
So
Closer.
it's closer. Yes. So it is a crossover. So combine.
Chill. That's enough.
So now combine the two pictures. Ignore the girl. Take the first picture and the type of the car. First half of the type of the car.
Chill. Wow, this is hard.
Wow, this really is hard. This is a recently released game. You all know it, I'm pretty sure.
Why zoo? There is no zoo.
Zoo, no, not Zoo
Yes,
crossover.
yes.
Yes, Animal Crossing. So, so yeah, Matis, congrats.
Nee, Jans.
Oh, Jans, okay, Jans, congrats, you were the first. So yeah. So this is Animal Crossing, and you win a calendar. And let's move on to the next game. So 3, 2, 1. Again, combine these two pictures. Guess the game.
Ja, niet meer weer kalender.
Yeah. So, Janis, can you guess 2 games? Yes. Okay, Mix, you guess the game.
Kamerstrada.
That's Wolfenstein, and you get a calendar. Please send us your post address to info@gamedev.lv and you'll receive the calendar. So that's it for this meetup. Thanks for joining, and see you in the Gamedev meetup 85. Bye.